Let's now focus on dark frames. A dark frame is just a bias frame, but with a very long exposure that typically matches the exposure of the light frame. Because there is zero light involved in capturing a dark frame, we assume that dark frames contain four things: bias, read noise, dark current, and amp glow. Dark current is an electronic phenomenon which causes electrons to slowly build up in pixels over time. The rate of this buildup is strongly influenced by the camera temperature. That's why astrocams are equipped with coolers. Cooling the imaging chip dramatically reduces dark current. The other benefit of coolers is that the imaging chip can be temperature controlled, which makes the dark current very predictable. Just as in bias frames, there is read noise. In dark frames, there is dark current noise, and this noise can be much larger than read noise. Amp glow is not a big problem for DSLRs. I suspect this is because DSLRs are not cooled. Many astrocams suffer from amp glow. My QHY294C certainly has amp glow. Amp glow is a short form for amplifier glow. On some imaging chips, there are electronics that generate enough heat that it locally warms the imaging chip. This causes the dark current to locally increase. Amp glow typically occurs at the edges of the frame. The latest crop of astrocams features zero amp glow. Let's talk about master dark frames. We generate master dark frames by averaging as many dark frames as possible. This averaging tends to eliminate the read noise and dark current noise. This leaves just the bias, dark current, and amp glow. Just like bias, the dark current is very predictable, but for uncooled cameras, the dark current can be much larger than the bias. The temperature control of astrocams make master dark frames very effective. My experience is that the dark current and amp glow are easily eliminated from my light frames when I use a master dark frame of the same exposure length and temperature. One way that astrocam suppliers describe dark current is with curves that look like what is shown here. I've shown the dark current curves for my QHY294C and for an ASI 2600 MC Pro. The x-axis is the temperature that the camera is cooled to. The y-axis is the rate at which dark current electrons build up in the camera's pixels. The units of the y-axis are electrons per second per pixel. I believe the units should be average electrons per second per pixel. This graph is deceiving because the average accumulation of electrons in the camera's pixels is trivial to compensate for. The black ADU logic in DSLRs does exactly this. It doesn't matter what exposure length or at what temperature you operate your DSLR, the average pixel value of your dark frame will always be equal to black ADU. If I added a curve to this graph to represent every DSLR on the market, it would be a straight line that equals 0 electrons per second. Better than both these astrocams. Of course, that can't possibly be right. It ends up that what's really important here is not what's being shown. Let me show you some examples of how dark current affects your light frames. You will soon see why this graph is misleading. You'll also see why you need to calibrate your light frames to eliminate the effects of dark current.